Hello and welcome to a short video about how to build an interface, an hardware interface into an MAME emulated arcade game. In this particular example we are looking at Star Wars. The reason, the background behind is because there was currently some discussion ongoing in the communities about the possibility to trigger the rumbler motor, which is located in the controller, each time when the player gets a hit from his opponents. And is this really possible by utilizing the software that we have, the MAME emulator, and it doesn't not even require to make any changes to the original ROMs. The way that is possible is to trigger whenever during the gameplay the shields is decremented, because this indicates a clear hit. Each time the player gets a hit, the shield count is decremented. All we need to do is to locate the memory area where this piece of information is maintained in the virtual memory space. And once we identify that, we just need to write in the game's game driver, the Star Wars game driver, a memory hook, which is called each time the game tries to read and write to this particular memory location. So how do we do that? Yes, the tools that we need for that are all for free, and most likely you have some of them already without knowing it. While I'm talking, you see here the screen with the gameplay, but on the right side here you see two attached windows, which is a debugger, which just scrolls here and through the disassembled code, and also gives an insight into what's going on in the virtual memory of this game. So really what we see here is the original game code, how it was coded by the original programmers in 1983. So this code is basically part of the game ROM, and is in binary version and can be easily disassembled. So, but how do we get there? So let's give me a chance to go one step back. Let's close those two windows. So we need to go to a command line where we have the MAME software installed, and if we scroll here through the directory, then we can see here MAME64.exe is the right one. So let's MAME64.exe, and the reason why we go to the command prompt is we want to start it with a parameter which goes by debug. So when we do that and start the game, then the debug window comes up, and this debug window is a feature, an element of the MAME utility. So if you have MAME, you have this debug utility for free, so to speak. So said that, there's in this window, which is already opened, we can see the disassembled program code. And if we then go to a key combination Control M for memory, then we get a second window, and we can attach it here. And when we now say debug run, then the game gets executed. Now the execution starts, and while it's do so, we can very easy watch how the lines of the code are executed. This here is a section where the CPU registers and data is visualized. So there are different address registers and program counter, stuff like that. And as you can see also here down below in the memory action, a lot of things are going on here. And this gives a window or an insight on what's going on. But of course it's kind of finding the needle in a haystack, so to speak, just to find in this huge memory area this particular 1 byte that is represents the shield counter. So I already did it before, so I know the exact location. But if we wouldn't know that, how can we approach So a very helpful information is when we look into the game driver. A game driver is a piece of program which is part of the MAME emulator. So each game that needs to be or wants to be emulated, or game family, has such a game driver, and so has it Star Wars, which is our example right now. And there's at least two sections that are quite interesting here. The one here, if we can look at the bottom, what we see here are how the content of the zip file. So when we're talking usually in emulation about the ROM file, we always think just about the zip file, but there's something inside the zip file, and those are the real ROM files that are just bundled together in one zip archive. And these files that you find inside the zip archive are exactly the ones that are loaded here in the memory. And in this section it tells exactly which file in the ROM, zip ROM folder shall be loaded into which memory area. So this is the virtual memory address space. And there's also kind of checksum, so to make sure when the emulator loads the software that it's not modified, not hacked, and otherwise it throws an error. So we have some idea about which files are necessary and should be located in the zip file. But it does not really tell that much which memory region is responsible for what, just roughly. We have here three sections. We have a math box ROMs, and we have sound ROMs, and here's ROM spaces. But there's another section that is a little bit more helpful. If I scroll upwards, there is somewhere, let's give me a second, the main CPU memory handlers, and they are very helpful. So they give a little bit more information about which address spaces contain which kind of data. So as you can see here, it's really nice commented here. So the very two sections here are related to all things graphic. As you know, Star Wars is a vector-based game, so we have here vector graphics. So the ROM section contains particularly the vector data that needs to be known to draw a proper shape for the TIE fighters, for example. And also there's some variable memory necessary for the graphics, which is the very first section. We particularly are interested for our purposes in RAM, in random access memory, which is basically the kind of memory that is utilized to maintain information during gameplay, like the shields, or others like the number of credits. So we can focus on each section, or all the sections that are sorry, that was wrong. What I told was right, but I was at the wrong source code. So we are back here. It's pretty much the same. As you can see, this describes how the memory is used, roughly at least, and we can concentrate on those sections that are related to RAM, random access memory, and they are not that much here. Here, for example, addresses for the input ports. Here for the tip switches have particular addresses where they are read out. We already talked about the graphics section at the beginning, so we can ignore that. And there are just two more sections in the RAM that are responsible for RAM game information, and this is the section here from 4500 to 45FF, which is RAM, and there's a second section more down below from 4800 to 5FFF. So this makes the task to search and identify the right spot a little bit easier, so we don't need to go from 0 to FFFF. We just need to have a look on these two sections. Nevertheless, it's still a little bit difficult and time consuming to check out these memory spaces. Sorry, this was unintentional. Was a little bit of a surprise. Okay, the game's still running in the background. What was the last sentence? Yeah, so we just need to focus on two sections on this huge memory, just the one here from 500 to 45FF, and the second one here from 4800 to 5FFF. I already did it. It's a kind of time-consuming task to have a look on what is changed and how, and what matches with the figures of the shields. To make a long story short, I already find out the right figures, and give me a second. It's where do I have it? 4860. So let's go here to 4860. It's currently 0 because we are game over, no game is running, but now let's make a test. So I throw in a coin to get a credit. Doesn't work. Once again.
The force will be with you.
A little bit loud. Nevertheless, let's go into the game.
Red 5 standing by.
And watch. Sorry. Watch closely here on the address, and it decreases with each time when the shield gets lost. So it corresponds with the shield counter.
Red 5, I'm going in. Use the force, Luke.
So I stopped this. It's a little bit loud. So you got the idea. So we found out the address where the shield is counted, and now we need to make to hook into the memory, to make a memory handler for this particular address. And again, we are back in the game driver. So exactly in the area that was so helpful to identify the RAM area, we need to make some definitions to hook into the particular address space. So when we look here, it's somewhere in this area from 4800 to 5FFF. So that means we need to split up this section into 3 parts. The section before the particular address, the address itself where the shields are stored, and the final section below. So to make it a little bit easier, we just need to copy that particular line two times, so we have 3 of them. Make blank lines for better readability. So, and the middle one shall become our shield section, or shield memory. And as I said before, it's exactly at 4860, and it's exactly 1 byte in length. So the end address is exactly the same, 4860. Then we need to limitate the previous section to exactly 1 byte before, which is 485F, and the final section needs to start right after the address for the shields, which is 4861. So we hooked right in the middle, exactly to the address where we need to have an access on. And now we have 2 sections here. The very first bit, which we already maintained, is the memory read section. So there goes all the stuff that needs to be done or executed when the game wants to read the information on the particular address. And there's a section for write, which is the opposite. So whenever the game, the emulated game, Star Wars in this particular case, wants to write to this particular address, then it goes to this section, so to speak. So where we are, 4800, same story as before. We just make 3 copies of that line. Copy 2 times. So the middle one will become the shields memory. And it's 4860. And 4860. And then again we need to limitate the previous section to 485F, and the last section will go to or start at 4861. And then we need to do something. It's not sufficient to just hook in there. We want to make sure that something is executed. So we now tell the game driver that a particular function shall be executed in the one case when the game wants to read from the address, which is there, and in the other case when the game wants to write to the address. Let's start here. So let's call it Star Wars Shields, and this is the read section. So we have an R for read, and down below we need to do something similar, but of course the function must be a different one. Star Wars underscore Shields underscore write. And with these two names, read and write, we now create functions that handle it. So it's static read handler, and it goes by the name that we defined previously. We need to make sure that it exactly matches. And then we define the body of this here with the parenthesis. And this function is called each time when the game wants to read the shield information, and then we need to return the particular value. And this particular value now we need to maintain in the C source code. So we need to create a variable for that. Let's create a variable 1 byte in size, and let's call it sv underscore shields, and let's initialize it with 0. So and each time when the game wants to know the actual value, we return sv shields, whatever is inside in this variable at the particular time. And of course this is not complete. We also need to make the same for write, static write handler. And again we need to make sure that we take exactly the same as below and paste it here. And again we need to have this parenthesis to define the body of the function. And the value, and this function is called by the emulated game by Star Wars when it tries to modify the value of the shields. And the data is provided here by an internal variable which is called data. And what we now do is that we say let our variable sv shields be equal to what comes with data. And so far what we did is already complete in terms of that the game still runs the same way. So what happens is when the game wants to write information, the emulator goes in this function and takes over the data that the game provides and stores it in this variable. And each time the game wants to read out the value, then this function is called, and it gives back the information that was previously stored here. So far we of course did not yet have an interface or something like that, but now we have what we need to get a hand on the trigger for this Rumbler model. But there's one more thing, because we want to only trigger the Rumbler model when the value has decreased, because the decrease of the shield indicates a hit of our ship by the opponent, by the TIE fighter whatsoever. So what we need to do is when the value comes in, we want to find out if the value that is now provided with data is lower than the actual number of shields, and only then we want to trigger the rumblers. So we create a Boolean variable, which is an expression that says just true or false. In the Boolean, let's call it is rumbler equals data smaller than SW shields. So when we get when the game tries to write a new shield value, we compare it with what we known before, and if the new value is lower than the actual value, then it's in decrease and hit, and then we want to trigger the rumbler. So we're almost done. What we now only need to do is if is rumbler then we want to do something. We want to trigger the interface. So I just make a comment here, trigger Rumbler interface. I don't have a Rumbler motor here, and also having kind of interface a little bit more complex. What I would do if I would implement this hardware interface, I would go, I think, with a serial interface. I think I would use some Arduino where I build up a serial communication, send a command there, and Arduino takes care of triggering the motor, and there's some rudimentary circuitry necessary that the motor runs properly. Because I want to go for that effort right now, and also I have no Rumbler here, I do something different. Let's just create a protocol. Let's write the information, some information into a log file. And I prepared something for that, so it'll be a little bit faster here. Let's see, where is it? Just copy over the information. Oh, exactly. That's it. So, yeah, instead of this trigger interface, which is not yet possible, I do something different. Paste. So what we do now is we open up a text file. Open a text file by the name starwarsshields.txt for appending information there. And if we indicate a rumbling, then we put out the shields with the actual count and just an indicator for the rumbler. And if there's no rumbler, just a modification in the shields, we write out that information. So that's basically all we need to for this proof of concept. Then when we've done that, we are ready to compile the code. So let's go into msys. So this is where I have the compiler. Now I just initiate a make command, and now the compiler recompiles this libretro 2003 core, which contains now our change for the Star Wars Rumbler trigger. Or not really trigger, but more an proof of concept. So it's already done. No errors were found. Now we can copy over. Let's see. Here, this is the compiled core, the result of the compilation. It's the actual date and time. Let's copy it, and then it goes into RetroArch. Where do I have RetroArch? Give me a second. RetroArch is located on. I'm almost there. RetroArch, app data, roaming. Here it is. So here we have RetroArch, which makes use of this. Let's see. Sorry. Yeah, let's clean this up. I delete this one. That was already a previous attempt. So I make sure that we don't have this protocol already. I cleaned it up. And then we need, of course, to go into the course folder and paste the newly compiled core. So that's that one. It's just the one that we compiled right before. So, and now we're good to go. Let's start RetroArch. We load our ROM file. Yeah, wrong directory, sorry. Scroll down a bit. QRS Star Wars. load archive and make sure that we load it with the right libretro core, which is the one which we just compiled. And here we go. Some warnings. Those warnings, I wasn't able to get rid of them, but they are unrelated to the change of the game driver. There's something wrong with my ROM file, but it's not caused by the change in the game driver. So the game driver already works fantastically. So now let's throw in a coin and start the game. So I just want to get quickly killed, so to speak. I just want to make a short demonstration about how the log file is written. So we're already down to 3 shields. Another hit, 2 shields. 2 shields left. So come give me one more. 1 shield left. 0 shields, 1 more hit, and we are game over. Yes, game over. So now let's see if we did everything right. Then we should have now an log file. Let's open it up, and as you can see, exactly how I expected it to behave. So we started the game. It was initialized with 6 shields, and then we had a decrease by 1 for the first hit, and for the next, and for the next. And only when we decreased, we had the rumbles triggered, and finally the FF is an indication for game over. So we successfully hooked into the memory space of one particular game for the purpose of preparing or triggering a hardware interface for the Rumbler motor in this particular case. I hope this was interesting, and that's it for today, and see you next time. Bye.